This video is for question 4A through 4C, where we're solving for x and y using special right triangles. Now, these problems could be solved using trig. However, we say special right triangles due to the fact that if we recognize that we have a 30, 60, 90 triangle, or a 45, 45, 90 triangle, as in 4B, here we also have a 30, 60, 90 triangle. We can turn these problems not into trig problems, but actually into similar figures, similar triangle problems like we were doing back in Unit 6. So what that means is on 4A, since I recognize I have a special right triangle of 30, 60, 90, I'm going to reproduce a 30, 60, 90 triangle that is similar to it. That is similar. And it's going to be 30, 60, 90. And I know the side lengths of this similar right triangle to be 1, 2, root 3. Right? This is just always going to be the same for any 30, 60, 90 triangle. We're always going to draw in 1, 2, root 3, 1 across from 30, 2 is hypotenuse, and root 3 across from 60. So from here, what I can do is I can set up two proportions to help me solve for my two unknown sides. So I'm going to go ahead and set up 6 with the square root of 3. Those are the two side lengths where I have actual number values, 6 times the square root of 3. And then for x pairs up with side or similar to proportional side 2, x over 2. And then y is similar proportional to the value of 1, so y over 1. And at this point, I have two proportions that I can cross multiply to solve. I'll do this one first. Root 3 times y is equal to 6. I would simply divide by root 3 here, giving me y is equal to 6 over the square root of 3. We talked about this in class. We don't mathematically like to leave square roots in the bottom of a fraction, so we multiply by square root of 3 over square root of 3, basically whatever's in the bottom. It undoes it, and then 6 times root 3 is 6 root 3. So 6 root 3 over 3. This actually reduces down to 2 root 3. The 6 and the 3 divide out. And I have my value of y. Same thing happens when I go ahead and solve for x here. So I multiply 6 times 2 is equal to root 3 times x. I'm actually going to divide by root 3 here. Giving me 12 root over root 3 is equal to x. Multiply the top and bottom by root 3, giving me 12 root 3. This reduces down to is equal to x. 12 divided by 3 gives me 4. We talked about this in class. In the denominator, this is mathematically correct for us to solve that. Okay, 4B. Once again, I have a 45, 45, 90 triangle, so I'm going to draw a similar 45, 45, 90 triangle here. I'm going to draw a similar triangle. That's my similar symbol. And those side lengths are 1, 1, square root of 2. So for this, 1, 1, square root of 2, always, 1, 1, square root of 2. We can again set up two proportions to help us solve for this. So I'm going to make two proportions. Whoop. The side lengths that match up here are 1 and 7 root 2. So we'll do 2 over 1. We'll do x next. X matches up with root 2. For y matches up with 1. And 7 root 2 over 1 in this case. Cross multiply and solve here. X is equal to 7 root 2 times root 2. We talked about this in class. We can multiply numbers inside the square root and numbers outside the square root, but not cross-pollinating. X is equal to 7 times 2, which is equal to 14 for my side length. When I multiply here, y is equal to 7 root 2. Lastly, 4C, we're going to draw another similar right triangle that is in the same vein of 60, 30, 90. It's going to be similar. Side lengths across from the 30 is a 1, hypotenuse is a 2, and this is a root 3. These special right triangles that I've drawn have been the same each time. We're going to go ahead and set up two proportions to help us solve for this. The side lengths that match up are 4, root 3 and a 1, so 4 root 3 over 1, 4 root 3 over 1. We're going to go ahead and match up y with root 3, and x is going to get paired up with 2, making it so that when I cross multiply here, I get x is equal to 4 root 3 times 2, or x is equal to 8 root 3, multiplying the 4 and 2 together. Leaving here when I multiply y is equal to 4 root 3 times root 3. Root 3 times root 3 is just a 3, so that gives me y is equal to 12. All right, each of these problems, I drew the similar right triangle in the same general shape and then set up two proportions because I was trying to find two values of the variable. If I only gave you one value of the variable, you wouldn't have to actually worry about setting up two proportions. You would just set up one. But there's my worked out answer. Great.